Hi guys, good to see you. Here I am broadcasting the solutions to homework 4.2. So initially what we see is a bunch of graphs that are plotting x versus time. So the first thing to look at when trying to determine the rate of this reaction, I believe that's the first question that I asked you, is to look and see if it's straight or not. And we notice this one here is not straight. So how it gets straightened out tells us what the rate order of this specific reaction is with respect to the kinetics. Now, if this was straight, we know that it would be zero order, but it's not straight, so it's definitely not zero order. So let's look down here at this bottom graph. Here we have 1 over x, and this is not straight either. If this was straight, we know that that would be second order. That's not straight. So here is our straight graph, and we notice that in order to straighten it out, the axis is ln of x versus time. And if you look at the sheet I gave you yesterday, look on your home group side of the sheet, you'll notice that if you graph ln of x versus time, and that's what it is required to straighten out this graph, okay, then we know that this is first order, okay? And as a side note, the slope is negative k. So this is first order graph of ln of x gives a straight line. And why don't we go ahead and write the rate law equation. So we know that the rate law equation for a first order reactant is going to be rate equals K times the concentration of whatever that reactant is. In this case, it's X raised to the first power. So again, let's go over this one more time. The goal is to straighten the line out. The only graph that gave a straight line was the one that plotted the natural log, or ln of k versus time. Any graph where the natural log of the reactant versus time is straight is said to be first order. Thus, it's first order, the graph of ln of x gives a straight line, and the rate law equation is going to be such. You don't necessarily have to show that one if you do not want to. All right, take care everybody, have a great weekend.